This is a solution for number 3 of the mock exam for exponential and logarithmic functions. Consider the functions f of x equals 1.25 minus e to the negative x, and g of x equals natural log of x. The diagram shows a sketch of the graph of f for the values x is greater than or equal to 0. The graph intersects the y-axis at point A, and the line L is its horizontal asymptote. Okay, so it intersects the y-axis at point A, and the line L is its horizontal asymptote. First thing it says is find the y-coordinate of A. Okay, so we want to know the y-coordinate of A. The hint says, what is the x-coordinate of point A? Okay, so it says that point A is where the graph intersects the y-axis, so that's the y-intercept, right? Well, we already know what the function looks like. It looks like 1.25 minus e to the negative x. So why don't we program that into the y equals screen? Because whenever you know the function in an applications exam, first thing you want to do is you want to program the function into the y equals screen of the calculator. Remember, the way you type in e to the x is here. You do second natural log, and that puts e to the something, and then you put negative x, and you always want to make sure to use this negative button and not the minus button if it's a leading minus sign. So I've programmed f of x into the calculator, and I'm going to find out where it intersects the y-axis. There's a couple ways to do that. One is we could look at the table. Remember, the y-axis, the x-coordinate of anything on the y-axis is x equals 0. So I could look at the table, and at x equals 0, y equals 0.25. So I already know that the answer is 0.25. But let me give you another way to do it. You could graph it. And when you graph it, it looks kind of like that, except it looks really small. I could immediately do trace, and when I press trace, it'll always start the cursor off at x equals 0, and it already gives me that the y-coordinate at that point is 0.25. If you wandered off, the cursor wandered off to the right, and you want to give it back to 0, you could press trace 0, and it'll go back to 0. Okay, and then just hit enter, and there it gives you that the y-coordinate is 0.25. Okay, so those are a couple different ways to find out that the y-coordinate of A is 0.25. What is the x-coordinate? Again, reviewing, the x-coordinate is 0. Okay, write down the equation of L. So what was L again? L is the horizontal asymptote. The horizontal asymptote, okay, so let me give you an easy way to find out the horizontal asymptote of an exponential function. You go into second table, and you head down either way up or way down. To head up or down, make sure that you're in the x column and not the y column. So first I'm just going to head up. And when I head up, you can see that the x values are getting more and more negative. Now, are the y values converging to a specific number? Look at the value right now. It's negative 3 times 10 to the 6. E6 means 10 to the 6. 10 to the 6 is like a million. Negative 3 million. Does that sound like it's converging to a number? No, it looks like it's just getting really, really huge. So let's go back. Let's go back to the origin again, x equals 0, and see, let's head for the other direction and see if that converges to a number. Let's see. There we go. So now we got 1.20, 1.23, 1.24. The changes are much more gradual. Now look at that. So 1.24, 1.24, 1.24, 1.25, and now it's just stuck on 1.25. So we have found that the asymptote is y equals 1.25, y equals 1.25, and the equation of the horizontal asymptote, you must write y equals 1.25, not just 1.25, because a horizontal asymptote is a horizontal line, and the equation for a horizontal line is y equals a number. Okay? All right. Let's see. We'll go. Another way to do that is you could do the graph, and then you could trace, and then as you move the cursor to the right, you can see that the y value is just getting closer and closer to 1.25, right? Okay, and eventually it probably does become 1.25. Now in real life, it's never going to actually hit 1.25. It's just going to get closer and closer to 1.25, but never touching it. But the calculator has a limited memory. So eventually it does actually get to 1.25 because to the calculator, it'll round it, you see? So it'll actually get to the asymptote value on the calculator. Okay? All right. C, for what value of x does g of x intersect the asymptote L? Okay, so in this particular case, we are going to program the asymptote into the calculator, 1.25, and we're also going to program the natural log of x function because that's g of x, right? G of x is equal to natural log of x, so we're going to program natural log of x in the calculator. The way you program natural log of x in the calculator is with the ln button right here. If it was log base 10, log, you would use this button here, but it's natural log. Remember, natural log is log base e, which is 2.71. Okay, so in natural log we're going to put in x because it's natural log of x here, right? And then we're going to put a closed parentheses. To make things a little bit easier to deal with, when we do intersections, it's better not to have three functions on the screen at the same time. So we're going to turn off one of the functions by pressing the equal sign here. Now you see there's only two highlighted equal signs. So now when I press graph, there's just going to be two functions. One of the functions is going to be the asymptote, which we drew at y equals 1.25. The other function is going to be natural log of x, and they do appear to intersect right there, right? And to find their intersection, remember we just do second calc intersect, number 5, and the first curve is, second curve is, and see it gives me the two suggested here, and we press guess. Okay, and the intersection is going to be 3.49, comma 1.25. I'm going to show you one thing that you need to be careful of whenever you use a function like log. Log is a function that has asymptote at x equals 0. Okay, so the asymptote of log is right at x equals 0. And because of that, sometimes when you start up the calculator, and we'll put the cursor at the middle, x equals 0. If I do second calc intersect right now, and it asks me what the first and second curve are. When I get to the second curve and it suggests natural log of x and I hit enter, it doesn't go. And the reason why is because if I have my cursor set at x equals 0, the cursor is still at x equals 0, but when it tries to locate the function natural log of x and you're at x equals 0, it doesn't find the function because the function doesn't exist at x equals 0. So you're pressing the enter button and nothing happens, right? So what you need to do is you need to move the cursor onto the curve by pressing a little bit to the right, and then you see it gives a valid y value now. And then when you hit enter, then it'll say, okay, yeah, I found it. Okay, so if you're ever in a situation where it seems like, okay, I'm trying to select the function's written up here in the left corner, but I'm hitting enter and nothing happens, it might be because the function has an asymptote right at x equals 0, and the cursor often starts at x equals 0. Okay, so that is the value, these are the coordinates of when g of x, which is natural log of x, crosses the asymptote, y equals 1.25. But of course, what they want to know is actually the x coordinate for what value of x. So actually, they wanted 3.49. Okay? And just one more thing. You remember how I highlighted the last two functions? I did not highlight the first function. Let me just show you what it looks like if I highlight all three. Then you get kind of a messy screen, especially if you're using a black and white calculator. You see three curves and straight lines on top of each other. A little hard to keep it straight. So then when you do the intersection, it's going to ask you which of the three functions you would like to intersect. And for example, this one, the exponential function, you don't want it. So the way you would say no is you would use the bottom and top arrows. So I would go down to the second function. I'd say, yes, I want that one. yes, I want the third function, and so I hit enter again, okay? So that's how I get out of, the calculator thinking that maybe I would like the intersection between y1 and y2. Actually, I want y2 and y3, okay? So that's a little bit confusing. So I prefer just to, like, at the very beginning, go ahead and turning off the function that I don't want, only leaving two functions to intersect, and then you can just, like, go ahead and press enter 3 times when you're answering, first curve, second curve, and intersect. Okay? Just some tips on using the calculator there.